Hello, welcome friends. Me Anila. The topic of my discussion is about important chemistry numericals. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you top 5 most important chemistry numericals which are actually related to moles, Avogadro numbers, empirical and molecular formula, limiting reagent and percentage composition of different compound. So in this video, I will tell you about top 5 most important chemistry numericals. Example number 1. Calculate number of moles of 50 gram sodium hydroxide. NaOH is a strong base because it dissociates fully in aqueous solution. We have to find number of moles of 50 gram sodium hydroxide. Solution. First we will calculate molecular weight of sodium hydroxide, that is 1 is the number of sodium atom into 23 is the atomic weight of sodium plus 1 is the number of oxygen atom into 16 is the atomic weight of oxygen plus 1 is the number of hydrogen atom into 1 is the atomic weight of hydrogen. After solving, molecular weight of sodium hydroxide is calculated to be 40 gram per mole. Now we will apply the formula of moles. Moles is equal to mass over atomic weight or molecular weight. In case of atom, we will write atomic weight. In case of molecule, we will write molecular weight. So 50 gram is the mass of sodium hydroxide divided by 40 gram per mole is the molecular weight of sodium hydroxide. So moles of sodium hydroxide are calculated to be 1.25 moles. Example number 2. Calculate number of molecules of 117 grams sodium chloride. Sodium chloride, as you can say that it is a table salt. The amount of sodium chloride is given 117 gram. We have to calculate number of molecules. Solution. First we will calculate molecular weight of sodium chloride is equal to 1 is the number of sodium atom into 23 is the atomic weight of sodium plus 1 is the number of chloride atom into 35.5 is the atomic weight of chloride. After solving, molecular weight of sodium chloride is calculated to be 58.5 gram per mole. We have calculated moles. Now, we have calculated molecular weight. Now we will calculate moles. We will apply the same formula as we have applied in the previous example. Moles is equal to amount over molecular weight 117 grams divided by 58.5 gram per mole. After solving, moles of sodium chloride are calculated to be 2 moles. Now we have to find number of molecules. We will apply the formula. Number of molecules is equal to moles into Na. Na is also called Avogadro number. It has a fixed value 6.02 exponent 23. So we will write moles 2 moles into, we will write Avogadro number 6.02 into exponent 23. After solving, number of molecules of NaCl are calculated to be 1.204 exponent 24 molecules. So this Avogadro number is a constant value. Example number 3. Calculate molecular formula of unknown compound having empirical formula CH2O and molecular weight 180 gram per mole. In this example, we have to find molecular formula which is the actual formula of unknown compound, and the simplest formula, also called empirical formula, is given CH2O. Molecular weight of unknown compound is given 180 gram per mole. We have to detect the compound by its molecular formula. Solution. First, we will calculate empirical formula weight CH2O, that is 1 is the number of carbon atom into 12 is the atomic weight of carbon plus 2 is the number of hydrogen atom into 1 is the atomic weight of hydrogen plus 1 is the number of oxygen atom into 16 is the atomic weight of oxygen. After calculating, empirical formula weight is calculated to be 30 gram per mole. Now we will calculate value of n. N is a whole number. N is equal to molecular weight divided by empirical formula weight. Molecular weight already given 180 gram per mole divided by 30 gram per mole. N value is calculated to be 6. Now we will calculate molecular formula. We will apply the formula. Molecular formula is equal to N into empirical formula. In place of N, we will write 6 into, in place of empirical formula, we will write CH2O. So after solving the molecular formula, we will multiply 6 with 1 carbon, it becomes C6. Multiply 6 by 2, it becomes H12. Multiply 6 by O1, it becomes O6. So C6H12O6, it is the molecular formula of unknown compound. So the compound is glucose. So we have detected the compound by its molecular formula. Example number 4. 30 gram of nitrogen reacts with 20 gram of hydrogen to form ammonia. Find limiting reagent. Nitrogen plus 3 hydrogen gives us 2 moles of ammonia. So now first of all, what is limiting reagent? It is that reactant which limits the reaction, which is producing less number of moles of product. So this is Haber's process. 1 mole of nitrogen reacts with 3 mole of hydrogen to produce 2 moles of ammonia. We have to find the limiting reagent. Solution. Molecular weight of nitrogen. First we will calculate molecular weight of nitrogen. Atomic weight of nitrogen is 14. So 14 plus 14 is equal to 28 gram per mole. We will calculate nitrogen moles. 30 gram is already given, divided by 28 gram per mole. After solving, nitrogen moles are calculated to be 1.071 moles. Now we will calculate molecular weight of hydrogen. Atomic weight of hydrogen is 1, but there are 2 hydrogens, so it is 2 gram per mole. Now we will calculate hydrogen moles. We will apply the formula 20 gram divided by 2 gram per mole. After solving, moles of hydrogen are calculated to be 10 moles. Now, according to the equation, 1 mole nitrogen produces 2 moles ammonia as discussed in the previous slide. So 1.071 moles nitrogen produces 2.142 moles ammonia. Similarly, 3 moles hydrogen produces 2 moles ammonia as discussed in previous slide. So 10 moles hydrogen produces 6.667 moles ammonia. Because as you can compare that nitrogen is producing 2.142 moles ammonia, hydrogen is producing 6.667 moles ammonia. Because nitrogen is producing less moles, so it is a limiting reactant. That is, it limits the reaction. So nitrogen is the limiting reagent. Example number 5. Calculate percentage of carbon, hydrogen and oxygen in glucose. So this we have to find percentage composition of glucose, since glucose consists of C6H12O6 carbon, hydrogen and oxygen. Solution. First, we will calculate molecular weight of glucose C6H12O6. 6 is the number of carbon atom into 12 is the atomic weight of carbon plus 12 is the number of hydrogen atoms into 1 is the atomic weight of hydrogen plus 6 is the number of oxygen atom into 16 is the atomic weight of oxygen. After solving, molecular weight of glucose is calculated to be 180 gram per mole. Now we have to calculate percentage of carbon, hydrogen and oxygen in glucose. First we will calculate percentage of carbon is equal to 6 is the number of carbon atom into 12 is the atomic weight of carbon into 100 because it is in percentage divided by molecular weight of glucose 180 gram per mole. After solving, percentage of carbon is calculated to be 40%. Percentage of hydrogen. 12 is the number of hydrogen atom into 1 is the atomic weight of hydrogen into 100 because it is in percentage divided by molecular weight of glucose 180 gram per mole. Percentage of hydrogen is calculated to be 6.667%. Percentage of oxygen is equal to 6 is the number of oxygen atom into 16 is the atomic weight of oxygen into 100 because it is in percentage divided by molecular weight of glucose 180 gram per mole. Percentage of oxygen is calculated to be 53.333%. So we have calculated percentage of carbon, hydrogen and oxygen in glucose. In this way we can solve numericals. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.